Assalamualaikum warahmatullahi wabarakatuh. And hi, my name is Muhammad Shafiq bin Muhammad Shahrul, and today I will present about the topic that we have choose, which is metal. So for my part, I will focusing on describing metals and the types of metals. Alright, firstly, metal is described as translucent, opaque elements and transfer heat and electricity effectively. As we know, metal properties are malleable, ductile and have a higher density than other elements. In general, metals are good thermal and electrical conductor. These materials are composed of one or more metallic elements and often used of non-metallic elements. For example, for metallic elements are iron, aluminium, copper, titanium, gold and nickel, while examples for non-metallic elements are carbon, nitrogen and oxygen. The most accurate method that we could relate is alloy. Alloys are a mixture of two or more metals formed together with other elements or material to create a new metal with improving mechanical properties and other properties of the base metal. There are two types of metals and alloys, which are ferrous and non-ferrous metals. Alright, first one is ferrous metals contain a large percentage of iron, such as steels and cast iron. So ferrous metals are magnetic, but it gives a little resistance to corrosion, while for non-ferrous it does not contain iron, but if it does, it only represents a small percentage of iron, and it is usually more resistant to corrosion and does not have any magnetic force. Thus, metals are important components to our modern industry and economy due to its strength and ability to use in a longer term. So that's all my presentation. Thank you very much.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Shafika binti Kamal Zaman. In this video, I am going to explain about the 5 metal fabrication processes. So the first one is casting. Casting is when the metal is heated until it becomes liquid, and then the liquid is poured into a mold or a die, and it is allowed to cool and harden until it turns into the desired shape that we want. And then the solidified part is ejected or broken out of the mold to complete the process. This process is ideal for mass production because we will use the same mold to create identical products. So the second method is rolling processes. In rolling processes, metal stock is passed through one or more pair of rolls to reduce the thickness or to make the thickness uniform or to impart the desired mechanical property. There are two types of rolling, which is hot rolling and cold rolling. So hot rolling is when the temperature of the metal is above its recrystallization temperature, and for cold rolling, the temperature is below the recrystallization temperature. Okay, so number 3 is the extrusion. Extrusion is when the workpiece is forced through or around an open or closed die. The diameter of the workpiece will be reduced to the cross section of the die. So when pressed around a die, a cavity is formed within the workpiece. So the resulting cylindrical item product is usually piping or wiring. So the next process is forging. Forging is when a hammer or die strikes the workpiece until the desired shape is formed. Like rolling, forging also has cold, warm and hot forging that depends on the temperature. So forge pots are widely used in mechanisms and machines that usually use high strength. Last but not least is the drawing. In drawing, we use a tensile force to pull the metal into and through a tapered die. The die then will stretch the metal into a thinner shape. So there are two types of drawing, which is wire drawing and deep drawing. We will use wire drawing to reduce the cross section of a wire by pulling the wire through a single or a series of drawing dies. In deep drawing, we will start it with a disc of metal and ends up with a cup by pushing the metal through a hole, or we also call it as the die.
Hi, my name is Sarah, and I am going to explain to you one of the application of metal, which is brake rotor. Brake rotor are widely used in the engineering industry. After multiple research, brake rotor that are aluminium-based MMC, which is metal matrix composite, receive worldwide attention the most since it has a better wear resistance, high thermal conductivity, and 50 to 60% attendant weight savings. In addition, it reduces inertial forces and provides additional benefit to the fuel economy due to its unsprung weight reduction. The lightweight characteristics of MMC can also increase acceleration and reduce braking distance. Based on the brake dynamometer testing, it states that it can reduce brake noise and have a more uniform friction compared to cast iron rotors. Last but not least, MMC brake rotors are produced by casting processes. Stir casting is a unique and prominent technique for the development of reinforced aluminium matrix composite materials. This process involves a liquid state fabrication technique which requires the incorporation reinforcing phase into a molten matrix metal to obtain a uniform distribution through stirring.
Hi guys, my name is Harry Daniel and I'm going to explain about the application of metals in mechanical engineering. The application for metals in mechanical engineering is the manufacturing of aircraft. Since early days, after the first successful flight done by Wright brothers in 1903, the shift to produce an aircraft from woods to stronger materials like metals was heavily discussed. Knowing the case, a German engineer, Hugo Junkers, designed the first metal-made aircraft in history that success in its experimentation. The J-1 monoplane are able to take off, fly around and land safely. This successful experiment that took place in 1915 revolutionized the aircraft production to produce aircraft with metals due to its higher durability that can withstand higher wind resistance and increased weight capacity. Meanwhile, in Soviet Union, the same thing happened where Pulisov Style 2, an aircraft made of stainless steel, was experimented in later years in 1934. In 1935, United States was able to produce one of the early passenger aircraft model named Douglas DC-3. The aircraft was mainly made of aluminium due to its lighter and strong properties. In today's standard, most aircraft were made of high-strength steel material, the example being most of the aircraft industry uses high-strength alloy 7075 materials which consist of copper, magnesium and zinc. This material yields strength more than 300 megapascal and have the maximum load up to 2500 megapascal without fracture when hardly stretched. Also, 80% of the airplane weights are mostly contributed by aluminium. Even so, some part of the aluminium on the plane are left there unpainted due to its anti-corrosion properties. That's all from me, thank you.
Okay, to conclude the whole discussion about this topic, the growth or decline of any industry depends on a number of factors such as demand for that product, number of players in the industry, relevant government, politics, economic factors and more. So usually, the trends are captured by the analysis on a global level, regional and the national. Here, we consider the overall global metal fabrication industry and outlook in the 2020 so far and the patterns observed in the US. And here we list 3 of it. And the first one is the market for metal fabrication is estimated to grow at an average growth rate over the next 2 to 3 years, and the growth rate seems to have shown over the last 6 months. Next, there has been an increasing demand for skilled workers who specialize in metal forming and shaping techniques. And last but not least is perhaps due to the previous setbacks such as recession and inflation, manufacturers are cautious but the market is largely stable. So this is also one of the reasons for a modest compound annual growth rate, which is known as CAGR in percent. So that is all from us. Thank you so much for your time and have a great day.